Welcome to VW 8.2. Today we'll be continuing our study of sequences and series. So first, it says determining whether a sequence is arithmetic. So I know it says arithmetic here, but that's actually pronounced arithmetic. So first, we need to talk about this definition. Like, what does it mean to be an arithmetic sequence? Essentially, it's going to be arithmetic if the sequence has a common difference. In short, you want to think of it as a linear sequence. Things that are linear are considered arithmetic. So our first example here, let's take a look. 4, 6, 8, 10. So I can guess the next term should be 12, 14, 16, dot, dot, dot. I can see here that the common difference equals 2. I can see that. It's going up by 2 every time. Dot, dot, dot. And that's enough. The fact that it has a common difference, I can write therefore the sequence is arithmetic. Next one. Show that the following sequence is arithmetic. Find the first term and the common difference. So let's find the first term. Plug in 1, you get 8. Just to make sure we understand, let's find the next 3. So if I plug in 2, I get 11. If I plug in 3, I get 14. If I plug in 4, I get 17. I can see that between every single term, I'm going up 3. So our common difference is 3. Therefore, the sequence is arithmetic. So far this should be pretty comfortable. Nothing really new here. We're just dealing with like a linear pattern, and we're just calling it something new, arithmetic. Now to get a little bit harder. It says find the 41st term of the arithmetic sequence 2, 6, 10, 14, 18. So if you think about it, the first term is 2, the second term is 6, the third term is 10, the fourth term is 14, and the fifth term is 18. The question is, what would be the 41st term? So to do that, we're going to first approach it logically, meaning like let's say in the SAT or the AMC, I want you to be able to think through a question like this without having to recall a formula. Just thinking about logically, we should be able to identify it's going up by 4 every time, meaning it is an arithmetic sequence. The question is, well, how do I get to that 41st term, right? To understand what we're about to do, I want to organize it a little bit differently. Here's our term number, and then here's our a sub n. So for example, the term number 1, the first term is going to be 2. The second term is 6, third term is 10, fourth term is 14, fifth term is 18. So I'm just reorganizing it. Dot, 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 41. What we're going to do now is instead of writing it as 2 and 6, leave the 2 alone. The 6 is going to be 2, and we get there by adding 4, right? That would make your 6. So 2 and 2 plus 4. So 10, I want you to think of it as something else as well. That's going to be 2 plus 4, which is our 6 right here. But then you add another 4. Notice how that's still 10. And hopefully right now you're seeing the pattern. The next one's going to be 2 plus 4 plus 4 plus 4. And the next one's going to be 2 plus 4 plus 4 plus 4 plus 4. So our goal is to figure out the relationship between these, right? 1, 2, 2, 6, 3, 10. Hopefully we're noticing that there's always a 2 happening. So my 41st term, there's definitely a 2. And I know there's going to be a bunch of 4s. The question is, how many 4s are there? Well, look here. On the second term, there is 1 4. On the third term, there are 2 4s. On the fourth term, there are 3 4s. On the fifth term, there are 4 4s. So in the 41st term, there should be 44s. So the answer should be 2 plus 160, which is 162. So therefore should be a sub 41 is 162, meaning that's your 41st term. Now, of course, there's a way to formulaically do it, because let's say instead of 41, let's continue this down, I wanted n. We would say 2 plus 4 times n minus 1. So notice how right here, that's the general formula. And that's what we're going to practice today. So for your notes, we can add that right here. Let's put a nice little box here. For an arithmetic series, the general formula is as follows. A sub n is equal to a sub 1 plus n minus 1 times d. So d is your common difference. A1 is your first term. An is your nth term, typically the term you want. And then n is kind of like your term number. So that's going to be the formula we're working with here. So let's highlight that. Yeah, it's good enough. So now, let's go to a little harder question. It says the 8th term of an arithmetic sequence is 75. So I'm going to write down, I know the 8th term is 75. The 20th term is 39. So part A says find the first term and the common difference. So first term equals something, common difference equals something. So first, we definitely want to find your common difference. To do that, we're going to think about what we're given. We know the 8th term is 75, the 20th term is 39. So the best way to approach this would be subtraction. We're going to do 39 minus 75 divided by 20 minus 8. Now you might be thinking, why did I do that? Essentially what I'm saying is, I want to take the 20th term, subtract the 8th term, and then do 20 minus 8 over the bottom, or on the bottom. And this should look familiar. This is simply another way to calculate the slope. Just in terms of our chapter now with a sequence and series, we understand slope now as your common difference. So 39 minus 75, that would be negative 36 over 12, which is negative 3. So right there, that's our common difference. But now it says find the first term. So to find the first term, we're going to have to think a little backwards now. Our formula we have is this. A sub n equals a sub 1 plus n minus 1 times d. We just found the common difference is negative 3. And I actually know the 8th term is 75. So what if I use that? 75 should equal the first term, and that would be the 8th term, so that's 8 minus 1. And now I can solve. So 75 should equal A1, that's going to be minus 21. So A1 must be 96. We did it. Okay, so part A is done. Let's go to part B. Find a recursive formula for the sequence. And then C is find the nth term of the sequence. Okay, so actually let's put those together. If I ever ask for the nth term, what this means is find the general formula. So we can just do B and C together. Let's draw a line like that. We'll write recursive here, then I'll write the general formula here. Now, in order to create these formulas, we're going to have to focus on 3 pieces. So again, we're talking about creating your recursive formulas. The first piece is to define the first term. So in our case, 36. The second piece is to write the formula. So a sub n is equal to something. What I've done up here is recreate the sequence for you. So you can see that the first term is 96, the second term is 93, the third term is 90, and you can see that we're going down by 3 every time. So that should help us understand what to do. For the second piece, I want to say the next term is going to be my previous term, except subtract 3. Now the third and final piece is to write for n is greater than or equal to 2. This part is particularly important because that tells you to start the formula from part 2 at the second term. So when you're writing these, you want to make sure you have these 3 pieces. First term, formula, when does the formula begin? Now let's do the general formula. The general formula is quite simple. Just write down the formula I gave you earlier. A1 plus n minus 1 times d, and plug in what we know. We know the first term is 96. We know the common difference is -3. And this answer right here is perfectly fine. Or you could simplify it and write -3n plus 99. Both of these would be perfectly fine. And that's it.